So in 1962, in October 1962, I sat through the Cuban Missile Crisis with a Russian communist who had come to work in my laboratory. And we trembled together every night. And it was a searing experience. And in a way, this talk comes from that. And so I've been concerned since then and active, slowly getting more and more active and in this arena. And I'll say a few more words about this. But basically, let's talk about the main points. So, unfortunately for us, nuclear weapons are still dangerous after the Cold War. The Soviet Union collapsed in 1991, late 91. Okay, thank you. Just interrupt when it's appropriate. Okay. Nuclear weapons, unfortunately, as I say, are still dangerous. They require attention, and similar in certain ways to climate change. And one of the differences between climate change, the probability of problems, in climate change, it's slow, steady, and increasing, and it's close to 100% probable that we're going to have very serious problems. With nuclear weapons, the way it goes is that they keep a lid on things. This is the fancy word for it is deterrence. We'll talk more about that. But what happens is if this fails, and it can fail, any complex system can fail, then there's a catastrophic, essentially an eruption, like a giant volcano, only this is more than you want to think about. So the probability, what I call the probability structure, is totally different, but the danger to the Earth is very similar to the Earth and life on it. And so if you're concerned with climate change, this is another issue, I'm afraid, to be concerned about. And the only possible solution is education and citizen involvement, being aware of the issues. So that's why I try to go around and talk about it. So first I want to give a small primer on explosive power. Okay, so in this, we're talking in equivalent quantities of TNT. So a hand grenade is less than a pound. The largest Mideast bombs are typically a few hundred pounds of TNT equivalent. A World War II bomb was the order of half a ton, a few tons. And the Hiroshima bomb was 15,000 tons, 15 kilotons. Okay, you'll see what this means in a minute. But you can see it's an enormous increase in explosive power.
Yeah. You're off by 3 orders of magnitude on pounds, right? If it's 15,000 tons, then it's 30 million pounds.
Yes, sorry. Thank you. You're right. I slipped by a factor of 1,000. I'll correct it next time. Nuclear fission was discovered in the late 30s. What happens is the energy release is 200 million electron volts. These are the same units as 110 is the voltage of your wall outlet. So you can see how powerful it is. A chemical weapon has an intrinsic explosive power per atom of 1 electron volt. So you can see the unbelievable increase in explosive power right here. What happens is, what was discovered is that a neutron comes into a fissionable material. There are two types of fissionable materials: enriched uranium-235, which is made nowadays in a centrifuge, and plutonium-239, which is made in a reactor. Okay? So you have to enrich the uranium, which starts off less than 1% in abundance, this isotope, to the order of 90% abundance. That's why you need the centrifuge. What happens is that the neutron enters a fissionable material, one of these two, and what you get are fission products, two heavy nuclei, a few neutrons, typically 2 to 3, and a lot of energy, a lot of kinetic energy, gamma rays, and so forth. And you get this total energy release of 200 million volts. Now, the way you make an explosive is you assemble something called a critical mass. And what happens if you don't assemble the critical mass is the neutron comes in, it fissions a nucleus, you get a few neutrons coming out, it might fission a few more, and then finally they all escape. But if you have a critical mass, it keeps multiplying. And each time it multiplies, you get 200 million volts. Okay? And it keeps going on and on. And each one takes a so-called nanosecond, 10 to the minus 9th seconds. As you'll see, it takes about 80 of these to get to the Hiroshima weapon. So that's less than a microsecond. Microsecond is a millionth of a second. In that time, this critical or supercritical mass gets hotter than the interior temperature of the sun, and it explodes. It blows itself up. It becomes less than critical in this millionth of a second, becoming that hot and blowing itself up and emitting the order of magnitude of this 15 kilotons. 15, 20, 30 kilotons of that order of magnitude. The way they did it in the Hiroshima weapon is they took two subcritical masses of uranium. They're shown, they're very little, and they slammed them together. They used a chemical, so-called propellant. It means a chemical explosion. They rammed the two of them together. The tamper just reflects neutrons, okay? And the thing went critical. They had a source of neutrons in there, which is not shown, and the thing blew up. And this is the simplest way to make a bomb. This is Hiroshima. One bomb, one city, 15 kilotons. You see what it means. It's incredible. Very few structures standing. Okay? August the 6th, 1945, about a third of the population was killed, half outright, half delayed through radiation and burns. Took the order of a year or so. This bomb is about a tenth, roughly a tenth as powerful as a modern bomb. And just so you realize the kind of damage these things can do, one high altitude bomb, modern bomb, exploded 50 or 100 miles in the atmosphere would disable every piece of your electronics, all your iPhones, boom, gonzo. Okay? It's that dramatic, the so-called electromagnetic pulse. So this is the kind of damage you can do to a highly sensitive infrastructure like we have, or the Russians have. And the Chinese are catching up, and so forth. So let's talk. From the beginning, there was an incredible tension between the views of the scientists who made the bomb in the first place and the people who were in charge, the politicians. Okay? And the atomic scientists were hoping that this weapon would be so terrifying that war would be ended. But they were also scared because they thought its use would trigger a nuclear arms race. So we were on some kind of precipice, and they tried to warn the government about this precipice, but it had no effect whatsoever. Basically, the policymakers have a tendency, a very strong tendency, to pat us scientists on the head and say, nice little boy, keep developing the toys we want. We'll take care of the big picture. Well, we see how they took care of the big picture. So what the scientists tried to say, us naive little fellows, there's no secret, there's no monopoly, there's no defense, and only international control will save us. And they published a book in 1946 called One World or None, okay, which I don't know how prophetic it is. So, on the other hand, the politicians thought, oh, my gods, we have a bigger bomb, we're going to use it for influence. So, it turns out the truth is somewhere in between. The truth as revealed by history, not the truth that had to happen, but the truth, you know, in terms of predicting what did happen. So the coercive influence of the nuclear bomb has been small. The evidence is the following. The Soviet Union took over all of Eastern Europe during the period of the US monopoly, which was 1945 to 1949. It only lasted 4 years, the American monopoly, as the politicians were warned in the first place. The prediction was 4 to 5 years for the Soviet Union to get the bomb. They came right in on target with that prediction. But anyway, the Soviet Union took over all of Eastern Europe. We hated it, we fumed, but we didn't start a war about it. China entered the Korean War during this period, and so forth. I mean, you could just see from history that our influence was minimal. Our coercive power was minimal. Okay? And fear also did not prevent an enormous nuclear weapons buildup, as the atomic scientists had anticipated would happen. So I made a little slide about the evolution of people's thinking about the bomb. First and foremost was fear. As I mentioned, compellence was next on the agenda. And Truman's Secretary of State, he went to his first international conference with the Russians, and he said, I'm going to carry the bomb in my hip pocket. Well, he got the famous Russian "Niet." They were scared, but you know, they didn't budge. When the Soviet archives got opened after the collapse of the Soviet Union, we found out how scared they were. But they did whatever they wanted anyway. Very interesting. So it was a mixture. And now what I'm talking about doesn't go linearly in terms of history. They all happened at once and they're contradictory, or they all evolved together. So there was a great loathing of nuclear weapons. We developed something that's been called the nuclear taboo, which means nuclear weapons have never been used. At the same time, there was growing familiarity. Other issues determined policy, and we built up to an enormous amount. Now, what this did, because of the buildup, so-called overkill, which I'll talk about in a few minutes, there are great risks. There are risks now, and I'm fast-forwarding to modern times right now, because the real reason to go over history is to learn from it, learn the lessons. And that's what I'm trying to do, absorb the lessons for today. So we risk undermining the Non-Proliferation Treaty. I'll talk more about this. We risk an accidental nuclear war. And these are small every year, but they integrate out, they accumulate. And the net result is unacceptable risk for the world. So the main thing that people have used to talk about the defense of having of many weapons is that you get deterrence. But the truth is that deterrence requires a very small number of weapons. 100 weapons is already overkill, and I'll show you the scale of it. And how do you know this? How do you know how many weapons is overkill? Well, it's very simple. Just count the number of cities in any country that you'd be willing to give up to win a nuclear war. Okay? How many do you get? 1, 2? They actually tried this on Gorbachev. They got to 2. Moscow and Leningrad. That's an actual story from Jerome Wiesner, who was head of MIT when that happened. Okay? It's an interesting story. But, so it's just a handful of weapons that would deter. And more brings instability. This is the message. Well, just remember this number. 100 is already overkill. Now, you notice this scale. We're in the thousands, 5,000, 10,000. This is the number of weapons that were built during the Cold War. We reach order of 30 to 40,000. During this period, there were constant talk in the United States about the missile gap, the bomb gap, the bomber gap, the throwaway gap. We were always told we were behind. Here are the facts, okay? The Soviet Union was always behind. Of course, they overbuilt. That was more or less predictable. And of course, it was terrifying. But it was already terrifying when they reached a handful. Fortunately, nobody ever used them in war. Then they developed intercontinental ballistic missile and so-called MIRV, which is multiple independent reentry vehicles. You can see a schematic. Here's one coming out of a nuclear submarine, boom, out from deep underwater. And what happens is you have different stages, and finally you release all these weapons. And in this picture, there are 3 or something, but you know, they can go up to 10 or 20. And you can target 10 or 20 cities or command posts or whatever. So they're multiple independent reentry vehicles. That's what MIRV stands for. And you had a tremendous multiplication in the number of weapons. One of those rises in that peak, I'm not going to go over it, is when we MIRVed the missiles. And no matter what we scientists who oppose this try to tell people, don't do it, please don't do it. You're just making things more dangerous for us. Nobody listened. They patted us on the head and said, go back to your labs, little fellow. You're naive. So here I am, one of these naive people talking to you. This one example shows you what we pack on one of our submarine-based, our submarines that launch ballistic missiles. So the maximum loading, this is the maximum, is 24 missiles on each submarine. That means 24 tubes that can launch missiles. And each one, at its maximum, could have 4 warheads. That's MIRV 4 times. So that means each tube, so we had 96 warheads. This was the maximum loading. They don't do this anymore. Okay, we're down factor of 2 or so from that. So you could destroy 96 independent targets. And if you wanted to, that would be 96 cities, if you could find 96 cities to destroy any place. Of course, then they had war plans with this munition dump and that, and they would reduce something to rubble 3 times. That was the Pentagon criterion, and so forth and so on. And who's naive? I don't know. And anyway, the warheads were much more intense than, I think this is croaking. I guess this needs more battery. Marilyn, do you have yours? This seems, oh wait, no. This is running out of pep. Anyway, the total explosive power on one of these is over 10 megatons. And that's like the order of triple. Where'd you put it? Oh, sorry. Okay. Okay, so this is triple, roughly, what all our bombing in World War II. Okay? So we have 14 of these submarines, about half of them are at sea, the British have a couple. So you look at overkill, it's extraordinary. What you would do with all this, I don't know, it's baffling. So I love this cartoon from the height of the Cold War. I'd be safe if I had one more. Reminds you of Dr. Seuss. Anyway, I think this was the spirit of things, and you can see why I loved it. It's a very old cartoon. This gives you a feeling for how many weapons there are. It's a few years old, so we have a few less. But it doesn't matter. I mean, we have such incredible overkill. So these are the strategic weapons. That means they're intercontinental. These are the more battlefield type. We used to have bazookas and depth charges and all kinds of nuclear stuff. And this is the so-called reserve. And typically the other countries, France, China, and so forth, have the order of 100, few hundred. So this is kind of the balance of things. These numbers are educated guesses because they're secrets in every country, but they're roughly right as far as we know. And the North Korean one with 10 is really the wildest guess. Okay, we all hope it's less than that. But you get the general picture. And so I'm not going to dwell on this, but there's a phenomenon known as nuclear winter. So one city, one bomb, multiple bombs, nuclear winter. So this is like a gigantic volcanic eruption. There was one in 1815 in Indonesia, when Europe and North America in 1816, the year after, had a summer without crops, literally without crops. Okay, and so this is a study of an possible India-Pakistan war with 100 Hiroshima-type bombs, and the estimate is they would emit 5 teragrams. I forgot what power of 10 that is. 10 to the 12th to something grams of smoke in 2006. And then you can see that the temperature, these are the average temperature anomalies from some mean for 30 years. And you can see it's been rising a few tenths of a degree. This is global warming that we're talking about. And then what would happen with such an attack would be an average. This is an average temperature around the globe. Okay? It would plummet by about a half or 2/3 of a degree centigrade, and which is more Fahrenheit, a couple of degrees Fahrenheit. And it would last the order of a decade. Okay? So the first winter would be the worst, or the second winter, and then it would start easing, but very gradually. So you'd have a global disaster. This is from a local war in India and Pakistan. Okay? And if such a war were to break out between us and the Soviet or Russia, it would be 4 or 5 times worse, with more or less the same time. Okay, I just don't want to go into all this gruesome stuff, but that's what we face if anything like this breaks out. So this is an unparalleled, an unprecedented climate change. And one of my colleagues made this great diagram. So what we have done is constructed this incredible, clever, from the point of view of technology, clever machine. It's called the Mutual Assured Destruction Machine. MAD is what they called the policy we had, Mutual Assured Destruction between us and the Soviet Union. And there are 2 buttons. One is the amount of power, and one is a button which is hard to control, but it's the accidental rate of explosives. Okay? It's a knob that you can only turn down politically, not technically. It's not a knob in a typical sense like you have a radio and you can turn the volume up and down. It's not that kind. It's the kind where you have to negotiate some treaties. That's the only way to turn the probability down. Okay, so this is this mad machine. We've constructed this exquisitely brilliant, earth-ending machine 13 billion years after the Big Bang. So that's it. So, the possible pathways to war. I'm gonna just talk about one, which is accidents leading to an accidental launch. Okay, I can't go through all of these. This is too long and complex a subject to cover, reasonably in one talk. But there are all kinds of scenarios floating around that are possibilities. So I'll focus on one that worries me personally the most, but it's not the only one. The India-Pakistan thing is probably the most probable. Who knows? So what we have is a policy of launch on warning. So the delivery times of missiles is 15 to 30 minutes. That gives the decision makers, so you're sitting at a command post, you're an Army officer or an Air Force officer, you're sitting at a command post, and you send the word in that you think there's a strike is happening, the enemy is striking. And that gives people about 10 minutes to make up their minds what to do. So that's an adequate time, you know, for deep reflection, isn't it? So, especially about the fate of the human race. So here you go, 10 minutes, 15 if you're lucky. Okay, so we have 900 missiles each on this alert status. 900, just remember how many cities there are. So the US president has an aide someplace in the vicinity 24/7 with the famous black box. Push the button. If you push the button, that sends out the command to fire. We assume the Russians have something like that. So in this complex system, you just remember that funny diagram of the probability of error. Okay? And all complex systems have fail modes which you don't anticipate. Fukushima did. Well, you know, every complex technical system has a failure mode. And the thing that people don't understand is that each side is vulnerable to what the other side is doing. So every day you get up and you look at the sunshine and you say, oh, marvelous day here, terrific. You're here because the Russians didn't fire. And if you were in Moscow or Leningrad, it's totally symmetric, okay? So you should keep that in mind every morning when you look at enjoy the sunshine, because you should. We all do. Okay, so it's well known that the Russian early warning system is much less robust than ours. Okay, so you say, oh boy, we're ahead in early warning systems. But that means we're behind, not ahead. But besides, if each side, anyone on either side launches, both sides are going to get it. So in a way, it doesn't matter who launches first. The other side is going to get it. These systems are vulnerable to cyber attacks. Just imagine if somebody gets into the system and manages to simulate an attack. What great mischief. Okay, you want to do us in? Everyone, people around the globe, I'm not giving up. For a while, I didn't want to talk about this. There were a couple of years. Then I realized there were a couple of years when I wouldn't talk about this, but because I didn't want to give anything away. But it turns out everyone knows it anyway. So I talk about it. Okay? And so, of course, this needs a political solution again. And again, only public pressure will change the situation. And by the way, it doesn't take a lot of pressure. If they get 1,000 calls in Washington about the economy, and they get 10 calls about this kind of thing, they are impressed. It's like that. So it doesn't take a mass movement to impress the politicians that something is going on in this arena. It's not symmetric. It's not the same. You know, we have a lot of evidence of this. The Nuclear Non-Proliferation Treaty is certainly a cornerstone of our security, international, our, and I mean collectively now when I say ours. I don't just mean the United States, I mean the world. Okay? There are the 5 agreed upon nuclear powers that were grandfathered in. They committed to disarm, but without a time schedule, so-called Article 6 of the NPT. A big fuss has been made of Iran. It's been a member from the beginning, but there have been problems. We have a definite violator, North Korea, and outside the treaty are 3 known nuclear weapon states who haven't signed. And the signatories have rights as well as duties. Okay, they have the right to peaceful nuclear energy, but they have to obey the obligations not to proliferate, to have inspections, and all of this is reviewed every 5 years. And the 2015 review at the UN failed to reach consensus on 2 issues. One was the Middle East. A lot of powers want to establish a Mideast nuclear-free zone, which in my book is a good idea, excellent idea. And the 5 acknowledged nuclear weapons states have agreed to disarm, but they're not doing it, and they're not moving very quickly, and people are tremendously dissatisfied with that, the non-nuclear powers, because they don't see us as keeping our end of the bargain. So the treaty, by and large, has been effective. I'm not going to go through all the details, but many fewer countries have bombs than were predicted in the 60s, by a factor of 3 or so. And the political norm is to renounce nuclear weapons and press the ones that have to disarm. So there are serious strains and serious strengths. And again, it's an essential treaty for world security. So one of the reactions to this stalemate with the nuclear powers not willing to, give a timetable or really working seriously to disarm as they're obligated to under Article 6 is people have started these humanitarian impact of nuclear weapons. And people really in the legal profession are talking about the fact that really, legally speaking, nuclear weapons are illegal. And there have been the international physicians for the banning of nuclear war, I don't have it exactly right, are pushing this humanitarian impact of nuclear weapons. There have been 3 international conferences, the last one in Vienna, and the Austrian government has backed this fully, which is very interesting. They're the only European country that has backed it. And we'll see how effective this is. It's a very interesting, what? Not to my knowledge. I think Austria is the only one. I could be wrong easily, but I'm not aware of Norway backing it. But anyway, even Germany's not backing it, which surprises me. I gave a talk in Munich and talked to my colleagues there about this, by the way. I got a lot of interest in it. Anyway, they want to really make nuclear weapons illegal, whatever that means, because there's no international enforcement. Okay? So that's the status of it. I'm personally rooting for it, but we'll see how it evolves. It's a very interesting development. And it all has to do with the nuclear, again, the nuclear powers not moving in a specific, well-defined way towards eliminating their weapons, reducing and eliminating. They're not being serious about it. That includes not just us. Unfortunately now, the Russians are actually relying more and more on their nuclear weapons. And we're in a bad situation there. I'm afraid it's going to last probably as long as Putin, but it's not 100% obvious. I don't know how much I'll talk about the Iran agreement, but basically, Iran, before the agreement of last July, was essentially a virtual nuclear weapons state. We reached an agreement in July, which is now moving into the implementation phase. And one of the interesting things that despite the negative things I said about cooperation with Russia, they cooperated fully in this enterprise. Okay? And the entire Western community, P5+1 includes Germany, showed remarkable unity. But it was a very difficult negotiation because there are hardliners and so-called realists on both sides. So both sides have this, Iran and us, particularly the United States. And this agreement was confined to nuclear issues because that was the only way to get any possible agreement. And just to show you how effective this is going to be, this is the stockpile in units of kilograms of enriched uranium. You see it was building up tremendously, and they have agreed to reduce it to an amount which is less than the equivalent of one nuclear weapon. Okay? And this is all extremely inspectable. I have to say there's a great scientific basis for this. The critics have said that it lasts 10 years. Well, certain obligations, I'm not going to go through this in detail, but certain obligations are permanent, all the non-proliferation things. Some surveillance things of mines and mills go on for 25 years. Some go on for 15 years. And some go on 10, 12 years, okay? And this is the uranium path to the bomb. You remember there were two types of fissile materials? The plutonium path was completely blocked by this agreement, okay? So if you want to ask questions, I'll be glad to answer them. But for brevity, I'll just skip to my personal conclusions that this was an incredible science-based model for all future agreements. This is the strictest agreement that has ever been made, and I'm very proud to be a friend of the present Secretary of Energy, Ernest Moniz, who is critical in negotiating this. And I think it's almost impossible for cheating not to be detected. And this agreement is not the end of all conflict between our countries. And, okay, there's intense opposition on both sides. But my comment is this was never the pressing arms control problem of our time. This became the pressing political arms control problem. It had to be solved, but not technically. And I just want to mention some indirect costs, which is the military budget, which is over half of our discretionary budget. This is the pie, 54% roughly. And just interesting what you could do by reducing a small amount of this. This is a calculation for Boston, the Boston area. We contribute to the Pentagon through our taxes close to $2 billion a year. Just to the Pentagon. This is, you take out taxes, you take 54%. This is what you get. If you look at just the requirements for the red line alone to build 50 cars, I don't advocate this as the only solution for the money, but just as an example, since we all had problems with the snow. This is timely. That's why I'm showing it to you. So we have no budget now for new cars. The feds aren't helping us. So a 10% cut in this would give us 50 new cars. You can think of plenty of other things to do with the money, and I'm not going to argue. Just an example. Okay? That's all. You can name your priority, okay? And I won't argue with any of these that I put up, okay? I'd be happy for all of them. So I'm going to wrap it up now. There are plenty of reasons for some guarded optimism about the outlook, like we've never had, and we haven't had a nuclear war. NPT is working modestly well. I think the budget constraints in Russia and the US may help us define a more sensible policy. I think we need to work on this. And my bottom line is always this: an educated and involved electorate is critical, and public opinion counts. This is my message. And there's plenty to do. I'll put this laundry list down at the end and when I answer questions, okay? And again, my same message in slightly different words. And can we dismantle this machine, is my question. I think that's our task. And I just want to talk about arms control organizations. I'm on the national board of this Council for a Livable World. We try to elect people to Congress, particularly the Senate, who will work against the nuclear arms race. Once people are in, we work with them for education and persuasion. The Arms Control Association is a tremendous source of information and its publication. There are people here from Peace Action. I'm always happy to see them. It's a wonderful action network. There's Global Zero. So there are plenty of people to work with. Okay? And you pick which one you want. I won't press the one I'm most closely associated with, but I like them all. And I'm just going to leave my laundry list, and thank you.
I'm going to get the microphone for questions.
Yeah. You can use this.
That's right. You can use it to answer.
Yeah, of course.
So as your chart showed, the US and Russia have made great progress in reducing nuclear weapons. Even 30 years ago, Reagan was instrumental in that, not my favorite president, and even talked about getting to zero, but it feels like for the last decade or more, that's kind of stalled, the reduction. Why do you think it stalled?
It's stalled because people are complacent. I mean, it's a gigantic political error. In thinking about the Iran negotiations, the intensity of negotiations that we put into it, over a few-year period, and certainly the last month or two, I was thinking, if you go to 1946 with the Baruch Plan, we never talked to the Soviet Union once about why we couldn't get together. If you go since 1991 and look at the history of negotiations, we never made a tenth of the effort that we put into the Iran negotiation. Iran, which doesn't even have a nuclear weapon. I mean, it is amazing when you look at it this way. So why is that? That's the question you're asking me. And I think it's complacency. I mean, in the long list of things that I gave, you know, people regarding these things sort of as totem pole deterrence, you know, they just let other issues come to the front. And because they think it's never going to happen. So, because nobody wants it to happen. So because nobody wants it to happen, they think it's never going to happen. But it's not going to happen because people say, oh, I'm going to really bomb the whatever word you want out of the other side. It's because it's going to be inadvertent. It's going to be an unintended consequence. And an unintended consequence is always your deal mañana, you know? That's my answer. If it's wrong, I could easily be wrong. Okay? I don't know. But it's a puzzle. You're asking a really good question, which I was going to sort of answer, but only sort of.
Professor, you're worried about a nuclear accident. That seems to be your biggest fear. We've had 70 years of the nuclear era since 1945. Mm-hmm. We've had, the United States has had a maximum of 35,000 nuclear warheads. The Soviet Union had upwards of 45,000 nuclear warheads in 1986. There have been innumerable occasions where there have been some kind of accident. You've had B-52s crashing. You've had bombs falling from aircraft. You've had false alarms and nuclear alerts in various nuclear bases in the United States. And yet, there's been no nuclear accident in the past 70 years. What makes you think that there will be one now? What makes you think, why do you think there has been no nuclear accident in 70 years? Do you think it's just luck? And if it is luck, then why shouldn't we be lucky for another 70 years, if not 1,000 years?
Okay, well, of course, that's a good question. I get asked that question all the time. Look, the first part of my answer is we are taking an unacceptable risk. The fact that none of these accidents ever led to a detonated bomb, in many cases, is luck. There were such close calls. You know, Eric Schlosser wrote a book which is, you know, like 3 or 4 inches thick with a listing of accidents and so forth. Just in the last week, we've agreed with Spain that we're going to do some cleanup for 3 or 4 hydrogen bombs that fell someplace in Spain. I forgot where exactly. What? Look, the United States and Russia, as time went on, got more and more careful about their safety system. So if you look, and this is a credit to both militaries, what you're talking about. But the point that I was trying to make from the beginning is that, yes, deterrence works up to a fairly large point, but there's an unknowable, uncontrollable breaking point in which people will not be rational. You know, something is going to happen and the system won't work. And in a complex system like this, it's, you know, in a way, it's luck that we got 70 whole years. It's both a mixture of deterrence and luck. And to count on it is not clever, okay? I mean, maybe it shouldn't be the major thing you worry about for the future. You know, global warming is much more certain. You know, I won't discuss that, but I think the probability is just far too high. It's small each year, but it accumulates. Okay, so that's one part of the answer. The other part of the answer is that people are worried about unauthorized, malevolent people getting their hands on the weapons, either a rogue commander someplace in Pakistan or someplace. And so if you eliminate these weapons, it eliminates that whole path. Okay, I know that's difficult, and I don't minimize the difficulty, but also you shouldn't close your eyes to the probability that something like that can happen. And that's probably the most likely path to a nuclear explosion. And it's probably not argument, you know, it's not a total disaster, but the likelihood is that we'll have blasts. We'll have a blast or two in the next 100 years if we don't change courses. That's all. I think there's a significant probability.
Professor, thank you so much for your talk. I have two related questions. The first one, just going off what you said, I think in discussing nuclear weapons issues with people who don't agree with me, the thing that I run into isn't that they don't think that deterrence isn't perfect, because I've talked to a lot of people who don't really believe in nuclear zero, but also agree that we're kind of on borrowed time. Where the disagreement is what's reasonable politically and what's like actually possible politically. And so I guess my questions are, one, what opportunities do you see for dialogue with people who aren't optimistic that zero is something that we can achieve, or who are more concerned with reducing the risk than eliminating nuclear weapons for good? And then also, do you see opportunities to link the issue of nuclear weapons with other mass movements, like you said, climate change or racial justice or things like that?
Okay, so first, yeah, look, the point to me is, first of all, I'm not wildly optimistic that we're going to get to zero in any short time frame, okay? When Obama talked about it, he said, we won't get there in my lifetime. I don't know if that's too pessimistic or not, but I understand where he was coming from. So I always put the question in, I parse the question into two parts. Number one, is it a good idea from the point of view of stability and arms control? And I think it is, and I also think we're committed to it, and it's part of the Non-Proliferation Treaty. So I think we should give it our all, okay? And we are, again, legally committed to it. Am I optimistic? No, I have to say. And that's why I personally advocate long-range things like education and dialogue as much as possible. That's my answer. So remind me, what was the second question again?
About cross-movement connections.
Yeah, I think the peace action people are better for that. They've been linking the issue. I mean, I've done a little bit in the budgetary things. The more general thing you asked about racial justice and everything, I mean, I'm personally for it, but I haven't personally, I don't see any easy linkage, okay? I think it's a generally good humanitarian impulse, and I'm certainly for it, but But a bitter joke that I always give, this is not constructive, but is that when the bombs go off, they're going to kill black, white, yellow, green, you know, and so, but that's not constructive. But
Well, I guess that's it, Professor
Okay.
Bernstein. Thank you so very much.
well, thank you.